So consider this given problem statement. So let m and n be the number of real roots of the equations, that is x square minus 12x, and here x written with some notation, that is the floor value of x, and it is, this notation is described as greatest integer less than or equal to x plus 31, that is equal to 0, and x square minus 5 times absolute value of x plus 2 minus 4, that is equal to 0 respectively, and this notation is already explained here. So in that case we need to compute the value of this expression, that is m square plus mn plus n square. So now we'll go towards the solution part, right? Now first of all, this is the given equation, right? So with this given equation I'll proceed ahead. So this can be written as x plus x square, right? So x plus x square minus 12x, and here plus 31. So what I am doing, I'm adding x on both the sides. So x, I'm adding x on both the sides, and this floor value of x, this floor function, I'll subtract. So this will be floor of x, right? So now this is consistent. So I have subtracted this value on both the sides. So this effectively cancels out, and then I have added x on both the sides, right? So now on proceeding ahead, so this can be written as x square minus 11x plus 31, that is equal to this particular function. So here this represents the fractional part actually, right? So here this x represents that this x can be greater than or equal to 0 and then less than 1. So that is the meaning here. So now proceeding ahead with this one. So here finally this expression can be written as, that is x square minus 11x plus 31. So this one within parenthesis, so this has to be greater than equal to 0 and less than 1, right? So from this we can say, from this we can clearly say that this quantity has to be greater than, this quantity has to be greater than equal to 0, and at the same time this has to be strictly less than 1. So now proceeding towards the next step. So for the next step, if you observe, if I calculate the discriminant for this equation, if I calculate the discriminant, that is, so let me not write this. So if you consider, that is 11 square minus 4 times 31. So this is something which is less than 0. And for the other one, if you observe, this can be written as x minus 5, right? For this part, so x minus 5 times x minus 6. So this is less than 0, right? So for the first part, that is this one. So for this one we can definitely write, that x for there is no real number as such, there is no real number in this set, that is the set of real numbers which satisfies this particular inequation, right? So this is the conclusion. And for the next one, for this one definitely we can write maybe in this step itself. So here it again says that x can belong to this 5 to 6 closed interval. So that is the meaning here, right? So finally we can say that, so this floor function, this floor function of x is equal to 5 here, right? So now I'll proceed with the next step. So here this one can be written as x square minus 12x, and here I'll write 5 in the next step, right? Because of this floor function of x is 5. So this one I'll replace it with 5, and in the next step, this can be written as x square minus 12x plus 36 that is equal to 0. And then for this one we can say that x equal to 6 will be satisfied. But here one condition is there, one situation is there, but x belongs to this open interval 5 comma 6. So in this case definitely we can say, definitely we can state that m is equal to 0. So from this we can definitely say that this value m, right, the number of real roots for this first equation that is represented as m, so m is equal to 0 because this 6 is not acceptable, right, because 6 is not included here. So therefore the count for the real roots for this particular equation is 0. Now proceeding towards the next step, so I'll take the next equation that is given to us, that is x square minus 5 times absolute value of x plus 2 minus 4 that is equal to 0. Now here I'll consider the situation when x is greater than or equal to negative 2. So with this, because for x plus 2 this negative 2 is the critical point, right? So now proceeding ahead with this condition, x square minus 5x and minus 14 that is equal to 0, right? And from this one finally we can say that this can be written as x minus 7 times x plus 2 that is equal to 0. That means the acceptable values for x will be, so x will belong to negative 2. So negative 2 is acceptable here because the condition is given that x is greater than or equal to negative 2. And then 7 is definitely satisfying this one. So these are the acceptable value for x. Now for the next critical component, right? So for the next critical component we can say that when x is less than 2, when x is less than negative 2, so in that case this one will expand this one as x square plus 5x plus 6 that is equal to 0, right? Because this because if I expand this considering this situation, I'll be getting this particular quadratic equation. So from this we can write x plus 3, this gets factorized to its linear factors, that is x plus 2 times x plus 3 is equal to 0. And from this if you can observe, the only acceptable value for x will be negative 3. Why? Because because we can clearly observe that x less than negative 2 is not allowed, right? Because x has to be strictly less than negative 2, x has to be strictly less than negative 2. So if you consider negative 2, so negative 2 strictly less than negative 2 is false actually, right? So finally the acceptable values for x is minus 3, minus 2 and then 7, right? So this represents, that is the number of roots for this one is 3. So finally we need to compute this particular value, right? So I'll take this one and compute this. So we can say therefore this value will be, value of m is 0, 0 square, 0 multiplied by m is anyway 0, right? And n square, that is 3 square. So 3 values are there for x for the next equation. So therefore 9 is the answer for this particular problem statement, right? So based on the situations and constraints, for the first equation I didn't get any value for m, so m was 0 because no real roots were being satisfied. But for this one, these are the acceptable values, that is negative 3 and negative 2 and 7 from the first part here. So n is 3 and hence on solving this part we are getting 9 as the final answer for this problem statement.